Hello, students of MAT215. I am in a Zoom meeting by myself with no video because this is a janky old PC. So I'm hoping that you see my screen. I'm recording this. I'm doing some examples from 1.2. I was pretty jumbled on Monday. I apologize for that. I don't think I have COVID. I'm still at home, but I do have the sniffles, and so I think my brain just got a little smushed. So I'm going to do some examples here. I'm going to kind of scroll and just give you piece by piece because I want to talk through the ideas. So these are problems from the book. In this one, you're given P implies R, and Q implies R, and you want to, Q implies not R, and you want to prove not Q. So I wrote my givens, and sometimes you don't use the givens right away, but think of it as just laying all your cards on the table. Here's all the stuff I can use. What can I do? And so you should always have that list of rules. I'll give that to you during quizzes. I will say you can reference that during this quiz. This quiz is actually going to be online because of me being home. And so I will say that while you're doing that, you can have that out. That slide that has all the rules. So if you look at this, you can also think about logically, what can you already kind of tell? A lot of times we're kind of just carefully proving things that seem obvious because you're all very logical people as science majors. So if you look at this, I have P and I have P implies R. Well, that seems like it should give me R. And it does. So that's my first step. Gave away a little too much there. So that's modus ponens on 1 and 2. If you have something and you know it leads to something else, then you have the something else, right? So that's what modus ponens says. P implies R, P is given. Well, then R is also achievable, right? Everything on the left are things that are currently true that I've deduced. So I was given 3, I've deduced that R is also true. The next line is Q implies not R, but I have R. That seems backwards. The next step is somewhat unnecessary. I'm going to go by the book and do things pretty tediously here and carefully. So if you look here, I really want not R, because if you look at 3, I'm headed towards modus tollens. Q implies something, and I have the, this makes it more clear, I have the opposite of that something. Think of this like a variable like X. That is the thing I have, and Q implies the opposite. So I must not have Q, which is what I wanted to conclude. So that's modus tollens on 3 and 5. So that one's fairly straightforward. I guess thinking about my line of thought, starting with these two, just where can I go? If you think about doing like trig proofs or two-column proofs in geometry and trigonometry, a lot of times you just, so maybe you're going to circle, but you just try to see what you can conclude. And so when I saw this, I pretty quickly found R, which is good because R does connect to part 3, right? So then I kind of had an idea of where to go. All right, so the next one, I'm given P and R, and P implies Q, and I want to prove Q and R. This is the same idea. It's going to require some other steps. I'm going to write my givens. I just have the 2 givens, but I have this weird given where P and R are stuck together, but P is all I need to imply Q. And then my answer has Q and R in it. So P and R is a complicated way to say that you have P and you have R. So I can write this on separate lines. I just wrote down P. That is simplification. So you have an and, you can always snap it off. You'll notice that in your notes, they always snap off the left one. You can really snap off either one. You're going to see kind of an unnecessary step in this one as well. But the way it's written, you can snap off the left one of the and say, put it by itself. So that gives me just P for simplification. And now if you, sorry, that's a typo. It should be simplification 1, right? I simplified the first one, not the second one. From there, you look at 2 and 3. Well, that's modus ponens again. I always get ponens and tollens confused. But you have P leads to Q, you have P, therefore you have Q. And so now I'm going to do a lot of Lego snapping and sticking back together. I have Q. I know technically I have R, it's part of this. And so I'll just snap them together, but it does require some steps. This step seems really tedious, but they're flipping 1 around. Again, that should be a 1, I apologize. To R and P, because remember, you're snapping off the left one. So there's R. And then I can conjunct Q and R. So Q and R, if you have 2 things that are true, you can stick them together as an and. And so a lot of this was basically the same idea as the previous problem, but kind of doing a lot of pulling apart with the ands and then sticking them back together. Think of and as 2 Legos stuck together. Okay, one more here. So I have this weird negative and thing. That should make you think of DeMorgan's laws, and then you have some negatives and some negatives. When you end up with just one thing you're trying to conclude, and you have a bunch of mixed together junk, you should probably try to bring in imply arrows. So there's my two givens. Before I do anything, the first thing is just a mess. So for peace of mind, I'm going to use DeMorgan's law. So that changes it to an or. And then that's a double negative. I'm just being careful. And then taking that through one more step. Double negation gets rid of the double negatives. Now, if you look at that, that is exactly how implication is phrased. It's written with P's and Q's on your notes, but not P or Q. That's P implies Q, so this is A implies B. Once you're there, if you look at 2 and 5, A leads to B, but you don't have B. That's modus tollens. You didn't have A to begin with, and that's what you were trying to conclude. Okay, so there are 3 examples for you guys. On your quiz, which is going to be on WebAssign, you can have your sheet out, your cheat sheet, from that slide that has them together, the inference and equivalence rules. You're going to have, mostly WebAssign's going to grade stuff for you, but the last one is you're going to have to write down an argument, and I'm going to grade that myself. And it's WebAssign's weird. It's written out of 83 or something. I'll convert it out of 20 points when I put it into Blackboard, but keep in mind you get a retake on it on your midterm if it doesn't go well. So we're doing that digitally so that we can go ahead and stay on track and jump to 1.3 on Friday. All right, thanks guys.